There are many obstacles that can block the path to a successful software project. When you come across one, it helps to think like a seasoned hiker and follow the trail marked by blue blazes around the problem so that you can get back on course and keep moving forward. Welcome to Blue Blazes Podcast. I'm your host for the journey, Jay Tower, and I'm a partner and principal consultant at Trailhead Technology Partners. In this series, we talk with industry experts who share their best tips for avoiding the pitfalls on the path to successful software projects. My guest on this episode of Blue Blazes is Mary Grygleski, a Java champion and the Director of Emerging Technologies at Liberty. With a background spanning C and Java, Mary spent over 2 decades as a software engineer before finding her passion in developer advocacy. She's a leader in the tech community, president of the Chicago Java User Group, and an organizer of an AI-focused meetup. In this episode, Mary and I dive into event streaming for distributed systems, how it enables real-time data processing, why it's crucial for modern architectures, and even its implications for AI. I'm excited to share the conversation with you. Well, hello, Mary. Welcome to the podcast.
Hi, Jay. Thank you so much for having me. I'm really excited today. Thank you.
Yeah, really excited to have you as well. And I'm excited for this topic. I know a lot of conferences that you and I both speak at where we see each other frequently. Right. There's quite a bit of content these days about distributed systems.
Yes.
And this conversation you and I are going to have today is going to be kind of focused on something specific in distributed systems,
yes,
which is event streaming. So could you give me kind of the quick definition in your mind of event streaming?
Sure. Yeah. So now there's event streaming, event-driven architecture, all these, they kind of related, so to speak. But first of all, to the event, it's referring to processing, right? Computing is a technique and that enables real-time processing. So event is event-driven. When something happens, we need to respond, do something about it. So anyway, so for streaming, it's interesting too. Yeah, when we talk about streaming, as we also hear too, right, on the consumer level, we're hearing like streaming, that Netflix is watching a video is streaming. Yes, because the data comes in streams, kind of like that. So anyway, so back to the question, event streaming is essentially, this technique or discipline of computing processing like a fast and responsive and real-time processing, and it's event-based and it's stream, meaning that there's continuous supply of data to it too. So that's how I think I would explain, I think in a more friendly way, so then other people can understand. Event-driven, event streaming, a continuous supply of data. So
okay, yeah. So an event is basically just something that happens. It could be a human face being detected on a camera, or somebody submitting a shopping cart, or like really anything, right? Somebody's temperature going over a certain number.
Exactly.
But streaming, let's focus on that word a little bit, because I think that's what makes event streaming kind of unique. There are some similar types of ways of processing events, things like queues, things like PubSub, that people are probably already familiar with, even if they aren't familiar with event streaming. Can you talk a little bit about how those things are similar and different? Jay here. Just a quick break in the conversation to share how Trailhead can help you tackle your toughest business challenges. When you're navigating uncharted technology terrain, Trailhead creates custom software solutions that put you back on the path to success. Ready for the next step? Get started with an expert consultation at trailheadtechnology.com/offer. That's trailheadtechnology.com/offer. Now back to the conversation.
So I think to me, that is actually very true. I also, in the beginning, when I started working in event streaming and actually even reactive systems too, that's how I first got into this space. And so that would be another thing, reactive, but they are similar too. So anyway, for I think for event, event streaming, PubSub, message queues, to me, I feel message queues and PubSub, these are more the techniques that enables streaming to happen. So streaming itself is more a bit of a on the conceptual level, a bit of a higher abstract. I think you could think of it like that. But it implies too like a continuous feed of data that can happen. And the pops up is a way of enabling that, is the mechanism to enable that to happen. As well as like message queues, a kind of same thing too. Like you have message queues, they imply like message comes in, and then when it's there, it gets picked up, and this can be this continuous thing. And you can have the client or the receiver side see some messages comes, and I pick it up and go, and only respond to it if there are messages like that. So I think that's how I would kind of differentiate between that on less of a kind of all academic way of explaining it. But I think that's what I would call it. Streaming is a bit more abstract level. So
okay. Now, you've made the analogy of the other kind of streaming that we all think about now, things like Netflix or other online video streaming platforms. One of the things that's kind of unique about video streaming is like you and I are both old enough that we probably remember watching TV shows live on TV that we can't explain to the next generation, right?
Yeah.
But in a Netflix show, I can pause and I can jump around in the stream to if I fell asleep, I can jump back 30 seconds and watch something again. Is there something like that too in event streaming?
Yeah, that's actually a very excellent question. I think it is very true. We're talking about streaming Netflix on demand, and you can watch it and it streams to you like that. And I believe, that's actually very good, because I've been only like looking at it computing sense and event stream too. There are also mechanisms in which you can kind of pause the stream, so to speak, and data is traveling, or it comes and it gets backed up or backlogged, all of these things. I think in that sense it is similar. I think that's a real good question. Nobody actually has asked me, so I have to actually think about it now. I think in some sense too, this computing streaming too also has a similar type of concept to it too. Yes, you can have data coming, streaming, but there are also ways in which you can take it, maybe temporarily storing it as well if you're not immediately processing it. Yes, I believe you can do it too, like that. So
okay, great. So that analogy for someone who's maybe learning about event streaming for the first time, sounds like is a good way to think about it.
Yeah.
Well, while you're thinking about that, let's talk a little bit about the platform that you're probably most familiar with, because I know I've seen you talk about this a lot in a past role that you were in, which is Apache Pulsar. Probably most people are, when they think about event platforms and event streaming in general, they probably think of a competitor, Kafka, as the most well-known.
Yeah.
So can you talk to me just a little bit about how those two products are similar to each other and how they're maybe different?
Sure. Yeah. So both Kafka and Pulsar too, they make use of also like pops up type of mechanism too. And in some ways too, actually for Pulsar too, it also is, you can also use it as a message queue as well, the way it works. But essentially too, there pops up and there's broker in between for handling messages. And, if you're a client, you can be sending messages, to the topic, and then it will get picked up by subscribers like that. That's why it's publish subscribe type. But the interesting thing, I think, also is that Kafka came out first, and that was like before Pulsar too. And then I thought was interesting because I was working for DataSex back then, and then we were at the time sort of collaborating, competing, I guess it's open source project, with another company who's actually the original Pulsar folks who started Pulsar at the Yahoo engineering team. So somehow it's funny. I thought they did it because they needed something to work on the cloud better or something this design, but it's actually not, because they were actually talking about something. Now it's actually slipped my mind. There was something too that they were talking about that that's why they wanted to use Pulsar for. However, the thing though, stepping back, if you kind of look at both products, Kafka came out and that was kind of before the cloud came out, become the main thing. It was, I think, early 2010s. And then Pulsar came out 2017 or 16, something like that. So that was like after the cloud becoming a bit more of the common thing. So the Pulsar's design too has been more of a cloud native, takes on more of a cloud native type of nature. So things, for example, like multi-tenancy is one of the things that it does. So it does quite very well. It's kind of natively, it can handle things very well. So think of like multi-tenants. The reason is that you can have, think of like an apartment building, and then you have some shared resources. But the thing is, each unit is independent. So then you can have messages already being stored in each tenant, and they don't have any relationship or isolated from the other one. So it's kind of nice in that sense. However, for Kafka, it's a bit more of a lower level, so to speak. So it doesn't have that kind of a construct to support this type of multi-tenancy, as an example for you. And then another thing too is like there's some couple more features too, and the multi-tenancy is one of the things. And then there's also Pulsar being more for geo replication a little bit better as well. Again, it's because of also it kind of came out at the time when the cloud is already the thing, and so they are developing it more suited for a cloud native type of environment. So therefore they're a bit more advanced in that sense, whereas Kafka, again, a bit more of a lower level infrastructural layer too. So I would think that would be like kind of some of the differences between the two. So
okay. And if I'm not mistaken, I think Kafka came out of LinkedIn and Pulsar came out of Yahoo. Is that right?
Yeah, that is correct. Yeah, that's cool. Yeah, you are aware of that too. Yeah.
Interesting. So probably similar needs from two different teams there that needed to be able to do something similar internally for their own applications.
That's right. Yeah. That's
right. Okay. Cool. And then in the cloud, I think there's a couple different options for how you can do this as well. If you're not using one of these platforms, you can use something that is more like cloud native. I know AWS has one called Kinesis, and I think Azure has one called Event Hubs. Yeah. Are these all kind of pretty similar products?
They are. In fact, all of these, yes, they are pretty similar. And AWS also has the SNS, I think the system, what is notification service or something too. So yeah, they also have these, they actually would do similar things, a bit more kind of a raw level, I suppose. Like this kind of a pops up broker messaging thing too. So yes, all of these cloud vendor too, they also have this type of construct in them, like Google, like you mentioned about Google too, right? And so Google also has their messaging systems as well. All of these major vendors have those things too. So
okay. Now I know in your most recent role that you are doing more cutting edge stuff like AI right now. So I'm curious, how do AI and event streaming play nicely together?
Yeah, that's actually an excellent question. That's something too. I myself, when I first, because of the work needs, right? That's how I switched to doing AI. And obviously, I was already curious too about AI. So that was when I was at DataStax, and all of a sudden, company says, "Oh, let everybody switch to we're supporting vector, data type in the Cassandra database." So that's why it's like all of a sudden, I switched to doing that. Anyway, so I welcome the opportunity, and the more I look at it, right, people are looking at Gen AI. The first thing people all talk about, all the investments, all the VCs go to is LLMs. Yeah, invest in the LLMs, make it bigger and better and more powerful, all these things it can do. No doubt about it. It is powerful in that sense. But to me, though, I feel like, let me kind of, I like to say it too. It's like people look at it like LLM is the gold mine, the gold, and all these. But the thing is, though, if you think deeply, the LLMs is powerful, but it can't by itself. It can't do much, right? Other than you ask me and I'll answer your questions. So in other words, we need to build a lot of things around it to make it even more powerful. By itself, it has a lot of limitations as well. So to me, when it is coming out, and the more I thought about it because of my heavier, interaction or experience with event-driven stuff and event streaming, all of these event stuff. So I naturally am thinking I was promoting it, talking about events is actually more of a natural way of processing for computers to process things closer to humans, because it's more asynchronous too. A lot of times, with events, you do something and you don't need to wait, and eventually you'll be notified, or something happens, essentially, right? So to me, I think I see a lot of synergy between these two disciplines. Kind of, we can make it kind of cross-functional together too, and essentially to generative AI, again, going back to the fact that you work with LLMs by itself is just a big glob of thing. It doesn't do so much. After then what, you ask a question, you get back the answers. But to make it more useful is to really leverage its strength and best of both worlds, and you get events. And these days, right, I'm starting to do some POCs. For example, I can have an agent to do different things, and while it is doing something, I can use an event-driven approach to these agents are all functioning asynchronously, but yet some are actually talking to an LLM to do some things, and I have multiple agents each talking to different LLMs, and they are doing different things, but you are thinking of it as like a big orchestra playing music. I'm doing a violin, this one's doing a trumpet. They all need to kind of sound good. But the thing is, they each individually are taking care of their parts. And I see it as, like event streaming, the event approach can come into play for helping Gen AI to become even more useful and building, apps that are more serving us humans better. And let's never forget, I always like to say, AI, as much as it seems like fancy doing all these things, but don't forget, it is just a tool. We use it to help us, not to have it control us, not to dictate us. But I want to kind of make sure that, we're using the best of, use the right tools for the right job and for the right purpose.
Yeah. So a lot of people in the AI space are talking about agents right now, right? That's the hot thing in AI at the moment. And I could see how if you're sort of piecing together a bunch of different AIs that are working with each other, that's basically a distributed system, right?
Yes, exactly.
It might, and we've all probably hit the limits on those LLMs where it can take some time sometimes to produce good content. You might wait 30 seconds, a few minutes, and that's very distributed. So that makes a lot of sense that they would work that way. Or is another good example, maybe RAG is another thing that people are talking about, retrieval augmented generation.
That's right.
Maybe like an event being driven by a new document being added to a repository and causing that document to get scanned and having vectors created out of it and that sort of thing.
Exactly. Yeah.
Nice. All right. So it seems like even with this AI buzzword that we're all getting caught up in right now, that distributed systems and event streaming could be very useful. I'm curious a little bit about what your experience is with when it comes to debugging distributed systems. How do platforms like Apache Pulsar help you kind of track what's going on in a very complex distributed system and help you debug it?
Oh, yeah. You have also hit another really good question about distributed systems. And I think it is never easy, right? Event-driven type of systems is not as synchronous like when we're learning, we tend to learn things in sequential order is easier. But now we're dealing with events, right? They can happen here or there, anywhere, kind of thing. So yes, it is never easy, I think, to debug distributed systems. And how do you know who is sending the messages at when, what time, what is the context at that time, for example. It's not easy. Now, one of the things too is basically, and I'm sure you have heard of too, is the event sourcing, using that kind of approach to register events that happens. And so rather than for example, like you're kind of like talking about, I log all of these changes to an order entry table. But at the end, you can only see what happens at that point in time. But I want to actually do event sourcing is whenever there's a change of state of that data, you capture that and then you save it too. So I think that might be some ways of being able to do backtracing and things like that. If you kind of, every time there are state changes, you're kind of saving it. So then you can kind of help you with backtracing, and especially what's for systems that can do trading. Stock trading, for example, is even high frequency trading, and so many events, a million gazillion events happening, and you want to be able to capture, at that moment in time what happened, or this block of things. Kind of look through the changes. You can replay because of this event sourcing way of managing data, how you save it too. So I'd say that would be one way. But of course, that's more of the application level. But there are also like debugging and all of these. So I think we need to have ways of in our code to be able to trace maybe all the their message ID, things like that, by timestamp, things like that we can kind of look up like specific things that are happening too. So, but I don't think, it's and then actually these days too, there are more kind of tooling out there too that can do a decent amount of job too, that you can actually make cross references if something happens, and how do you kind of relate it back to some events that happen, what generates and what is the source. I think the modern tooling can help us with that as well. So
Okay, very cool. Another thing that I know people worry about with distributed systems, and I'm interested in your perspective on how event streaming is impacted by this, is things like durability or failures or that kind of thing, right? So one of your jobs goes down that's processing a queue, or the queue itself, the server the queue is running on, goes down. How do you make sure that events get where they're going to, that they get processed by somebody and only one, only processed once, and all of those things in event streaming?
Mm-hmm. Yeah, totally. So it's basically too, if for the platform itself should have built-in capability to ensure that there are no duplicates, or there are also, like, for example, messages get sent but maybe not received or not getting a response. So you need to have some kind of timeout mechanism as well. And maybe in some case too, the messages didn't get picked up, does it go into a dead letter queue, things like that. So I think the platform itself is usually, for example, like Kafka, Pulsar, they would have built-in capability to handle this kind of exception case too.
Mm-hmm.
So so those things are usually the platform should have mechanism to handle that.
And so, based on you saying that, I'm guessing I know the answer to this, but I've been doing a talk for the last few years on distributed systems, specifically microservices architecture. And I've been a little surprised by how many people have tried to build their own message queue or message bus kind of a setup. And obviously, when it comes to things like failures and retries and guaranteed delivery and all that, my guess is that you probably would not recommend trying to do that when there's great things out there like Pulsar and Kafka. Is that true?
Yeah, I think, well, I do have to say, sometimes, yes, using framework platform is helpful, but there are also cases, like you said, maybe there are systems in which folks might find, I need some custom solutions that the platform doesn't provide. So in that case, then it makes sense, right, to build your own, or maybe if you can extend the existing platform, and it allows you to override, right, extend capability or override it. I don't see it as an issue if you want to write your own. But let's say, to me though, I find, right, we want to be efficient when we do things. We don't want to reinvent the wheel. So I think once we determine if we can't find a tooling to do the job for us, then we'll have to write it. But otherwise, if it is there, don't try to rewrite. There are many things to do in any project. So we just have to be efficient in how we spend the time. Although it can be fun, but
it can be fun. Yeah, I think maybe that's the reason why so many engineers have tried to do it themselves. It sounds like a fun problem.
That's right.
Well, just a couple more questions for you. The last one on event streaming I want to ask you is somebody who's new to event streaming,
Sure.
maybe new to Pulsar, which I know is the platform you're most familiar with. Where do they get started if they want to try it out, learn more about it? What's the best resources they could go to?
Oh, sure. I think you can go to their respective. These are open source project, or Kafka too is got tons of things that you can actually go. There should be documentation that you can go to. Likewise, Pulsar also has their documentation too you can go to. But there also, if you search on the internet, you'll be able to also find like resources to learn too. I have to also admit I haven't been working as much of these messaging platform as much, but I'm sure too there are maybe different playgrounds, so to speak, their online way of learning. I believe those are there too. So just do some searches. Yeah, I'll be able to find information on those. Yeah.
And if somebody searches for Pulsar, there's a decent chance they're going to find something that you made.
That
talk
could be.
about Pulsar.
Yeah, that's right. Yeah, and I have some video recording as well. So yeah, that's right. Yeah.
Great. Well, let me ask you the one last question I like to ask all my guests. This has been a really helpful and interesting introduction to events streaming, so I appreciate that. But I want to ask you a more general question, which is on the theme of this podcast, which is making software projects more predictably successful. What other topics besides event streaming, or what other people should we be talking to on that topic?
Oh yeah, sure. For event streaming, okay. Or actually, we already talked about, maybe somebody comes in and talk about generative AI. Maybe that might be, if you haven't already got the folks talking about it. Definitely too. I think AI would be interesting, and also more like for event streaming, I think something to do with data pipeline, data flow, and transformation. I think those will also be very helpful too, I believe. Yeah. And then if you get into generative AI, if you want to touch that topic, right? Everybody's talking about it now. Maybe talk about some of these language models too. I think it may be interesting too, or which one to use for what purpose. Those kind of cases will be useful too, I believe. And use cases too in general. Yeah. And then for speakers though, well, although these are not specific like AI speaker, but then I like to recommend like Venkat, Dr. Venkat Subramaniam, if you want to have him too. He's a well-known more in the Java field, but he also talks about JavaScript too and other things. He also will be running an AI conference too in March, so March April timeframe. So yeah, and he's wonderful to talk with too. Yeah, I'd like to recommend. Yeah.
Great. Those are all excellent suggestions. I appreciate your time and your expertise on event streaming and all of those wonderful suggestions. Mary, thanks so much for your time today.
Thank you so much, Jay, and you asked the best questions ever. Thank you so much, and thank you for having me.
It was a pleasure. That's the end of this Blue Blazes podcast. If you're interested in hearing more conversations like this one with industry experts focused on how to make software projects more predictably successful, make sure to subscribe. Trailhead can be found online at trailheadtechnology.com, on Twitter, LinkedIn, and Facebook. Until next time, thanks for listening.